Hello everybody, Chaz Large here with another Fix It video for you, and on the bench today we have got a quad system, a quad 404 preamplifier and a quad, where are we? Can never remember where the numbers are on these. It's on the front, isn't it? Yeah, it's a 405 amplifier. I'm not sure it's a 404 front end because there's no numbers on that, but I'm pretty sure it is. Maybe a 402. Whatever. Anyway, the owner got in touch with me after seeing my videos and said, I've had this in storage for a long time, haven't used it, haven't got it out, would like to use it, had lost the interconnecting cable, so he went and bought one on my recommendation, so we have got the connecting cable. And he said, but obviously with all the usual sort of problems with old equipment and capacitors, they may have failed. If I plug it in, it's going to blow up and all that. Personally, I think it will come on and it will work just fine. But I'm going to have a look inside before I put any power in. I think that's a wise thing to do. He did say that there are some problems with the controls. The slider for the balance was very noisy. Doubtless all of these switches are a little bit noisy, but we'll find that out. These things are just the bits of the wrapping that he used when he sent it to me. Basically, it's a bit of the old lagging foam pipe, and he's cut it into little corners to go on there. I think that's a good idea, actually. I may adopt that idea for stuff when I'm sending fragile stuff back through the post, or shipper or whatever. Anyway, let's take the top off and have a look inside. So we'll run the titles, as they say, and I'll be back once I've got the lid off. Right, to get into these in the preamp, it's basically two screws and the whole of the back and top cover slides off like a sleeve. To get into the power amplifier, there are four screws underneath for a bottom panel, and then there's two screws here which actually don't need to take those out unless you're going to take the side panels out. But basically there's two other screws go up here, and then the top cover lifts away like so. Inside there is a nice piece of, I'm not sure what that is, whether it's just heat resistant material, whatever, but it obviously dissipates the heat. I don't know, I'd have to look up what it is. But as we can see, doesn't it look lovely and clean? Look at the way it's made. Let me just bring in this other camera to show you. That's what I like about these old quad amplifiers, is these are handmade. You know, all the wiring is done. This is all done by somebody, you know, sat there at his bench. And back in the days when this was made, which is 1981 possibly. Yeah, I think it's 1981. There's a date there. Here it is. This is the power amplifier. Two big power amplifier boards, big power supply. This is just basically a big whacking great big transformer. That's what it is. And we've got two smoothing capacitors for the two supply rails, and you've got fuses in here, fuses on the other side. Basically they're mirror image, these two power cells mirror image that side to that side. But I'm just looking around in here and I honestly cannot see any sign of capacitance leakage or anything like that. But everything in here all looks okay. I mean, these look like capacitors. I'm not 100% sure. I'd have to look in the manual. It says on here it's got 116, so that may well be, yeah, this is a capacitor, 100 microfarad, 16 volts. But there's no evidence of that leaking or bulging or anything like that. There's one there that's got some white marks on it, but I think that's just the heatsink compound that's got meshed on there. Yeah, that's all it is. There's no leakage on that one. However, looking across at this one, there's a capacitor here on this board that looks a little bit iffy. So you can just about see, if I find a pointing device, just in here, this capacitor, there's like a little crust around that edge. Has that capacitor split and some of its electrolyte come out? I think it has actually. So it could well be that this capacitor here has failed or will fail imminently, and we could be looking at changing this, possibly all of them. Now I've got that potential evidence of a capacitor potential failure. Quick look on this one as well. On the preamp board we've got a capacitor here. That looks to be okay. Let's turn it over because I can see components better on this way round. Yeah, similar sort of thing here. I think these capacitors are on the beginning to fail, because if you look at, compare these two, look, this one looks nice and clean and that bit's flat. This one looks slightly bulged and it's got like a little crust on it. So I think these are primed to fail. Yep. Okay, so I think what I'm going to do, I'm going to start on the power amplifier first, because what we could do, we can get the power amplifier going, we can put a signal into it and see if it's okay. But what I want to do is to take this board out of here. Alright, so quick little look. I've obviously got the camera as evidence, black and braid, red, brown and red stripe, black and red. So we can then unplug these. We should then be able to reach in and undo these clamps which are holding the heatsink onto the front panel there. I think that's probably the easiest way of getting this card out. Yeah, I'm pretty sure that's the way it's going to be. So let's gently tease these off of here. Nice spade connectors. Nice pliers to push them off. So I'm gripping the spade connector, pushing against there and pulling with this finger. That way I'm not twisting anything out of shape. So that should be okay. So then we should be able to get a fairly long screwdriver. So if you're planning to do any work like this on things that have got big heatsink on, do make sure you've got plenty of heatsink compound for when you put it back in. Don't rely on the old stuff, it may have dried out. This one, it seems to be okay. So we'll just take these screws out and pop them in a little tray. I haven't even looked at the circuit. I've got a manual for one of these, but I would suspect before I even look at it, 2N3055s. No, 1750-56. Yeah, 17556 or 7556. I'm not sure that's a 1. Yeah, it is. So probably the equivalent, Japanese equivalent of 2N3055s or similar. So yes, we can see a little bit more clearly now on this. If I hold it there and adjust the focus once again, where's my mouse gone? We can definitely see there's a lot of bit of a crustiness on there. It's not split as such, but there is, the way that these are made, I think, if you can catch it with a glimpse, I can just about see it. Yeah, you can just see that there's like a circle, and I think what happens is as these begin to fail, that they ooze out of the top of that circle. So let's test them in circuit first. So I'll get my component tester. So that's a 4.7 at 40 volts. Yep, C10 that is. So let's just hold my probes on it. So it should be testing, and it should say it's a capacitor. It's reading as a resistor, 327 ohms, typical. So it looks like I'm going to have to take it out to test it. The trouble is with taking things out is you can end up making them fail. And just holding it on there is better. No, it still thinks it's a resistor. Okay, so soldering iron on. Okay, soldered iron's all warmed up, so I think the quickest way of getting these this capacitor out of the board without overheating it is to use my solder sucker, which is just here, because if you overheat a capacitor which is slightly leaking, it may change its value and such, though you can't really tell if it's gone out of things. So minimal heat when you're taking out a capacitor, you want to check. Obviously we can't check it in circuit, or we've tried, and it just measures as a resistor. So if we're going to take it out, clean the soldering iron, and quick warm and plunge with the plunger. I think this is quite old solder because it's taking a lot of heat to warm it, but I think we've cleared it enough. So we should be able to now wiggle the old beastie out. And if you're working on components, changing capacitors for the first time, then always check, if you're taking out electrolytics, which way round it goes. Now it came out that way. There's no markings on the board. There's no marking on this side, but one side of the capacitor has got a positive on it, so that means positive on this side. So I'm just going to use my pencil. Right, positive on there, so I know. Doubtless the service manual's got a diagram which shows that, but not all circuit diagrams and board layouts have got the markings of capacitors, you know, especially electrolytics. So you need to be careful when you're doing that to make sure you get a note of which way round it comes. In fact, it's probably even better not to take it out until you've checked the position. That's probably what I should have done, is made a mark on the board first. That's probably a better idea than marking it once you got it out, just in case you drop it and then you're left. So either way, make a note. Right, now let's try again with the old component tester. Put positive on positive, why not? And switch it on. And it recognises it as a capacitor this time, and it says it is 73,331 nanofarad with an ESR of 14k, or 0.14k, sorry, 28% of V loss, so 73,000 nanofarads. But considering that says 47 or 4.7, can't quite make that out, can you? I think that's a 47 at 40 volts. So having a reading of 70 odd thousand nanofarads is not good. Right, so next thing to do, have a little look at the service manual. Let's call that up. Okie dokie, so we can see on here C10 is just this one here, and it says it's a 47 microfarad, and if we look at the layout, it says C10 is 47 microfarad, 40 volts. Doesn't give any special markings on that, but we'll get a 47 microfarad of similar size and voltage out of the can. We've got one here at 63 volts. So here we now have a 47 microfarad at 63 volts. Let's check that in comparison to this one. and we'll do a test. And that shows 48 microfarads. So I think we can definitely say that this wee beastie is no good. Let's just test it again. Yep, it's now changed to 2200 nanofarad. Right, I think this one's gone. So I think all of these red electrolytic capacitors need changing. So basically that's what I'm going to do. Draw up a little list, go through all the electrolytics. I mean, there's 3 on that board, 3 on the other board, so that's just 6 on this board. Looking at the preamplifier on this board, I'll just tip it up. We've got 1, 2 on there of that kind. I can't see any others of that type, the red type. So those 2, I think we'll definitely change those 2. We've got 2000 microfarad silver tops. In fact, yes, in fact, there's another. Let's just go back to the close-up and look at this one. Get it into focus for you, and you should be able to see there's like a little ring of white crustiness around there. There might be on the other one as well. I can't see, it's under that board. Yes, it's covered up by this cardboard, so can't see that. So I think we'll change those 2 as well. All the rest are little ceramic capacitors, which are probably as good as the day they were made. There's no tantalum. Oh, there is a tantalum bead there, look. Call them tantalum beads, but it's a tantalum capacitor. I might have that one out and change that one as well. So I think the best thing to do is to battle on with this and change all the capacitors. Right, here we are back with this quad amplifier rebuild of replacing all the capacitors. At least that's probably the first stage. It's taken me a while to get all the components. As you can see, I've got a selection of components. The big capacitors I sourced from Radio Spares. They're very high quality. Checked out their specifications. Even though they're a lot smaller than the original capacitors in the big amplifier, they should do the job equally as well. Various other components that I got that I didn't have in stock. I had some, but not enough, so I thought I'd batch order some. First lot got shipped within a day of ordering, and then I waited and I waited, and unfortunately they sent it via Every, and Every lost it. So I had to go back to the supplier, and he very much apologised and sent me another batch via Royal Mail, first class post, and they arrived within 2 days. So that was good. Had to go also to Ferndale Electronic Supplies, get some other capacitors which DM Components didn't have. So hopefully I've now got the full kit of capacitors for both the amplifier and the preamp, so we should be okay. The only things that I haven't ordered specifically were any replacement little tantalum capacitors. I took the one, here it is here, out of this board. It's 100 microfarad at 3 volts. I tried searching for these. I couldn't find any specifically, but they probably are available. So if you were to have a look for them, you would find them. But I tested it and it's absolutely tests fine. It's not short or anything, and it actually tests as virtually the correct value on my component tester. So my experience of tantalum capacitors, or as I grew to know them originally, was they were called tantalum beads because they look a bit like a bead, was that they go short circuit. I've had quite a few of them go short circuit, but I've never had any that just change value or go out of spec. So they're either working or they're not. That's my experience. So I'm going to leave these in there. I'm going to put this one back in, leave those in there, change all the electrolytics, which we know have changed values because they've all got crustiness and breaks and so on. So I'm going to change all the other capacitors, leave the tantalum beads there, and hopefully, fingers crossed, that will enable us to get back to full working condition. So what I think I'm going to do to get an initial test done is change on the two sub boards, the two amplifier boards, the electrolytic capacitors. I'm going to leave the big capacitors in this amplifier as they are. My tester can't go up that high, but it doesn't show them as being dramatically different to testing a similar capacitor that I know is good. So I've checked it against one of these and they read the same. So I'm not so suspicious of that as I was. That change, that circle around there, is where I'm pretty sure I heated it up. But I didn't get that on camera. So when I get these boards done, I'm going to do this test again and show you on a comparison with this one that they are the same. So basically I may not need to replace these at all until after I've tested it. So I'm going to put those to one side and just concentrate on the sub boards for now. One little thing I meant to mention is that C17 on this board is in fact it's an electrolytic, but it's non-polarized. And if you look at the circuit diagram, you'll see that it's non-polarized, and it's part of the circuit that is used to buffer part of the energy of the output. So I had to get these in special from Ferndale, 63 mic 10 microfarad, non-polarized. So when you look at these in comparison with an ordinary capacitor, ordinary electrolytic capacitor, you can see that there is no positive or negative markings on this. So that's just a special little note I thought I'd mention in case you ever decide to change capacitors on here, or if you come across it and you think, oh, that's a weird looking capacitor, there's no markings on it. That's because there are no markings on it. It is a non-polarized capacitor. Okay, so onwards with the replacements. So now I'm going to go through, put this one back and change the other capacitors on the other board. Okay, having changed these three capacitors, I thought, why not? We ought to check them, really, didn't we? I'm pretty sure that replacement is just the only way it is, but I thought, well, let's just check it anyway, just to show the reason why we are changing these capacitors, because we suspect that they are failing. So we've got one here which is a 100 mic at 16 volts, which hopefully you can just about make if I get it there. Yeah, 100 microfarad. That's the positive, so let's stick the old test meter on there and switch it on, and it's testing. The battery inside is okay. It says it's a capacitor, and it says it's a 10 microfarad at 10.25 microfarad. Well, I think that has definitely changed its value, don't you? Right, let's try another one, and let's try the next one, which is a 47 microfarad. Positive this side, not that makes a lot of difference. And turn the meter on. And it says unknown or damaged part, so can't recognise it even as a capacitor. Let's just do that again. Just another test. Nope, doesn't recognise it apart, so there's definitely one that needed changing. And this last one here, which is another 100 mic, positive on that side. Don't know why, I can't remember why these are labelled positive and negative, but so just 1, 2 and 3 on the little kit that this tester comes out. So this should be a 100 mic capacitor if it's okay, and it's testing it as 8,000 nanofarad. Don't think that's 100 mic, do you? No. So I think that proves without doubt that changing these capacitors is the right thing to do. So we've now got both of these capacitors changed. I've checked the little capacitor, the little tantalum bead down there, which is again another 100 mic at 3 volts. I'm not going to take it out because if it's not faulty, it doesn't check as short circuit, but we can put our test meter on it in circuit and it should give us a rough idea if it's right, if I can put my probe onto it correctly. Now when I designed this box I put this one in the wrong place. I should have moved it over there. Never mind. So it's an unknown or damaged part. It's in circuit. Should I take it out? Yeah, probably best. Right, let's get the old soldering going, and then we'll take that out, but certainly those three are for the bin. So far on this amplifier we've identified 6 capacitors, of which I've got a box for it, faulty parts. 6 capacitors, most of which are bad. One in the other one, the tantalum bead in that one was okay, tested okay. This one we're going to check and see if this tantalum bead is okay as well. I very much suspect that it is okay, and the tester doesn't like testing things in circuit too much, but we will find out imminently if need be. Let's just double check where we're going. Those 2 legs there. One more heater. On the positive side, you can just about make out a little positive. I think that's a positive part there. Not sure. Oh no, positive is this end. Well, that's interesting. That's very interesting. So there's a capacitor. Let me just get that in really close. This is very strange, I think. So you can see C2 is here, and there's the positive mark for it. But when you actually look at the capacitor that was in circuit, the positive end is at this end. So ever since new, this capacitor has been in the wrong way around, assuming the circuit board is correct. But we will check the actual circuit, but that's the way it's come out, with the positive end at this end, unless that means plus 3 volts. I don't think so. There's nothing else. So C2 goes to a junction of R16 and R5, R1. I think that's ground. So if we have a look at the circuit, C3, C7, C5, C1, C2. Yes, C2, negative side goes to ground. That's marked up wrong. Unless that positive doesn't relate to that. Well, the fact that it's right underneath, where it says C2, you would think that that's the positive end, wouldn't you? But that's ground. That bit's all ground. The positive side goes to a junction of R4, which is there, and R5. Yep. So that's definitely the positive end. That plus is wrong. So that's obviously a screen print error, and if people have been following that and replaced that capacitor and put that capacitor in back to front, it may have caused problems. Let me just have a little look at this one. In fact, I have done the same thing. I took that capacitor out there, and I'm pretty sure I've put it in according to the diagram on the board. Can I get a lantern in there to see? My battery's running flat on my torch, so I can't see it. My phone's in the other room. Thought I had another torch somewhere. Great, isn't it? Anyway, I'm going to double check that, because I'm pretty sure I've put that in wrong. It probably makes very little difference. It's one of the feedback capacitors on IC1 between pins 3, which is ground, and pin 2, which is the inverting input, I would think. So it's probably going to make very little difference, but I need to triple check, so I'm going to take that amplifier board out again. Turn it on, and it's saying it's a 110.9 microfarad, and it should be 100 microfarad, so that capacitor is okay. Like I said, these tantalum capacitors, they rarely go wrong. When they go wrong, they just go short circuit. They rarely change value, in my experience. Yours may be different. If your experience is vastly different to mine, and they don't go short circuit, they change value, then do please write in the comments below. I'd love to hear from you. So let's solder that one back in there straight away, quick smart. And let's just double check. Right, so the positive is this end. And I'm going to scribe a little positive on that end. If I can find like that, and I'm going to scrub that positive off there because that's wrong. It's not referring to anything else. Next to it is resistors, and there's polypropylene capacitors. There's nothing else that are positive or negative. There's no diodes or anything there. So let's pop this one back in, because I'm pretty sure this amplifier module is now okay. So I'm going to pop this one back in, get that camera out of the way. Let's put some sticky gungy stuff on that. Just a touch more. I'm not going to spread it about too much because it's got a lot spread about, so I'm pretty sure that just putting it on there and wiggling it about will spread it enough of it about. Especially when we clamp it into place. We drop one screw. Doing up the connection, the screws in the diagonal pattern, like you would do on the nut hubs of a car. Wheel. There we go. Now, I'm pretty sure these wires are still in the same orientation as when they came away. We'll just get them on there and then we'll double check our plan, which was red, black, coloured, black and braid. Yep. So there's all the connectors back on. So we are at the moment, apart from the big capacitor here, we are now capacitance changed on the main amp. Okay, so I've prepared this now ready for testing. Got some speakers connected, I've got the mains power in, but there's no power to it yet. And I'm going to test the voltages on here. Now obviously if something drastic has happened, we're probably going to get something like, I just realised that integrated circuit has fallen out. Now I did notice that when I was taking this apart, one of the cables to this amplifier board was unplugged. So I'm just going to, before I do anything else, I'm just going to check the resistance on the red wire, which is the positive supply rail, and see what that reading is for there. It should be the same. Let's switch it to ohms, and it helps a lot if we do that. So that's got 340, yep, that's pretty much the same, because I think that's directly connected to the supply. Yeah, 2k. So there's no dead short on it. So check there's no dead short on the negative. Well, there won't be, no, because they're both connected in parallel to these two supplies. These red and black wires go to the two boards. So meter on the negative supply, meter on to volts DC, and ready to switch on. If all goes wrong, it's going to go bang, lots of smoke, and we've got a loud hum on the right hand channel. Okay, didn't get, oh, so 50 volts on that side, minus 50 volts on that side. So we have a fault on one channel, and I'm pretty sure that that is that board. So at least we didn't get any noise out of here. I wonder if we can just touch the input with our finger and see if we get any output from this channel whilst we got it on. It's obviously not blowing fuses or anything. No. Something desperately wrong with that channel, isn't there? So really and truly, we need to now see if we can isolate what the problem is, see if the fault is with just this board or something else. Now obviously somebody at some stage or other has had a go at this, because that power cable, the red wire, was disconnected on that side, which I didn't do. I think best thing to do is if I disconnect this whole board again and then just try this output and see if we get any kind of buzz through here. It may be that both sides have failed. In fact, actually just looking at this, I'm wondering whether, let's use my other meter quickly to test it. There's a fuse on here. Has that fuse failed? It has. That fuse has gone. Has the bottom fuse gone? Yeah, in fact I think both fuses have failed. Starting afresh this morning because the last time was I wasn't feeling great, so I made a few bad deductions. I've disconnected the positive and negative supply to both of these boards. We've discovered that the fuses are gone in this board, but the fuses in that board are okay. Not sure why they've blown, but we'll obviously check that. I've disconnected the positive and negative supply of that board as well. So hopefully if I power it on now, I should get minus 50 volts and plus 50 volts across these two capacitors. Let's have a little look. So there we've got minus 52 on that one, and on that one we got plus 52-ish on that one. So I would say the main power supply part of this is actually working. The capacitor's discharging, as I would say, quite normally. Let's have a look at resistance to ground on the inputs. So let's just have a little look on this amplifier. So the positive comes down into that fuse and goes through to there. So that's one side of the fuse. So we got 600 ohms on that one, and on the negative side 600 ohms as well. Let's do the same on this one. So there's one fuse there, and on that one we've got 9k. On this one we've got 16k. Yeah, so I think the reason why this fuse blew is because we've got very low resistance to ground. 600 ohms on the negative fuse and 600 on the other side. So there's a good possibility we've got a fault on this channel. Having changed nothing on there but all the capacitors on there. I think we could probably test and hopefully get a good output on this amplifier. So let's try putting that back. And this channel. Pull my little insulators off. Let's just stand it up that way for now. Reconnect that to our common ground. Power off at the moment, so we need to go on to the fuses, our positive and negative. So here we go, one channel. Oh, we're on ohms. Blow my meter up, why don't we? There's 50 volts on that side. Minus 50 volts. And those fuses are okay. So, not getting out any output. Oh, hang on. Connect the speakers, it would help. Yeah. So we got input. So I'm pretty sure that channel's okay. Whew. So now we've got to find out why this one is reading badly on this channel. So what on this amplifier board is going to take those resistance readings down? Let's have a little look at the circuit diagram. 12 issue 3, so that's the circuit, correct circuit for it. So we've got obviously the capacitors, we've got the, from the fuse we've got the output stage transistors. So TR9 and TR, I can't quite read it, TR10. So let's go back onto ohms. Emitter of TR10 reads 4 ohms to ground. And it should be on the negative supply rail. That's a very low reading, isn't it? Let's go to the emitter on TR9. Also reads 4 ohms base. 500 ohms. Base of that one. 25 ohms. So I would say the base of TR10 is okay, but the base of TR9 is wrong. Let's compare it to this amplifier, and on this one the base is no ohms, the emitter is no ohms. Well, that amplifier we know is working, so I think we've got a faulty set of output transistors by the sound of it, because the collector is also reading wacky ohms readings. Yep, I've got a feeling we've got a faulty output pair. Yeah, I definitely think we're going to have to take some transistors out of this board and check them and see what we get. Right, here we are back with this amplifier. Let's disconnect it from the rest of the unit and take this amplifier board out once again. I could work on it in place, but it's just, I want to be able to do some checks between this board and that board, and it's a bit awkward having to keep turning it over. So I'm going to take this one out completely. If I've got to change the transistors, I've got to take it out anyway. All good fun, isn't it? Right, put the old kitchen rail towel around the end there. And just hopefully stops too much of it. Getting everywhere. I suppose we could take the screws out really, couldn't I? So, pretty sure the problem is with the actual output pair. So I think one of the first things I want to do is to desolder these two. Let's bring in the other camera, and then you can see exactly what I'm doing. Yes, we are. Okie dokie. So quick little look at the rest of the board. I can't see any other problems with it. Where I've replaced these capacitors, let's just triple check that I've put them in round the right way, just in case I hadn't. And that was positive, and that was a positive at that end. Yep. Right, so those three are correct. Yeah, I think we're going to find that these output transistors are shall we say gone. So desolder them. Push back. Yeah. Let's try the other one. Right. Just get my pliers and give it a wiggle. Yeah. Right, so they should now be clear. So base emitter, we're on ordinary ohms range. Yeah, data gone. I'm pretty sure these are gone. So a couple of 17 5 5 6s, and carefully take the mica washers off and find another tray to pop them in. And let's have another look. And I didn't have that shown before, sorry about that. So we'll go on the collectors to the emitter, and that looks pretty much dead short to me. Go around the reverse direction. Yep. That one's definitely gone. as has that one. Yeah. But that way, and that's yeah, emitter collector short. Let me just go on to the actual working amplifier, and if we go on to this transistor here, go collector to emitter, and it reads a good 1K and 1K between base and emitter. 1K. It's not diode, we're not in the diode range, we're just checking ohms, but there's no shorts there like we have collector emitter. Right, yeah, I mean that's in circuit. So if we have a look at this one and go here, collector emitter, that's way up, yeah, and we're on 40 kilo ohms range, so these are very high kilo ohms. Yep. So we need to find two of these transistors, 17556. Okay, well I did a bit of research on the transistors that I had. None of them were suitable, and if you look at the service manual, the two output transistors that are in there are 17556s, and the manual shows that they are either that or they are 2SD424s. Again, searching for that, scant information available because this is quite old, but I did a bit of research and found various websites, support forums and things where quad amplifiers have been discussed, and output transistors, and several people had said that the nearest best equivalent is an MJ15003. So thankfully, good old Radio Spares came to the rescue. I ordered a couple of those. Also in those discussions were the operational amplifier, which is in there, which is a TL071. That's recommended to be replaced by a different one, which I purchased some of, just for the sake of having them available should I need it. So I've got some of those to drop in as a replacement should the operational amplifier in the pre-driver area of the circuit. But there's also, if the output transistors have failed, then their drivers TR8 and TR7, which are 40872s, if they've failed, and we won't know until I check them, but they can be quite happily replaced with tip 42Cs. The C is relevant because it's the higher voltage, it's 100 volt end of the range, and I've got plenty of those in store. I've used those many times before on other circuits, amplifier circuits. So we've got two new output transistors. What I'm going to do is I'm going to put those into the circuit, wire it, solder them in, and then I'm going to compare it resistance wise with this other board on here, which I've got in, and then do sort of resistance check to check and see if anything shows up significantly. But let's get these transistors in place first. So there should be 5. I don't know why they do packs of 5 of these. I suppose it's a standard value. Let's bring that back up out of the way so we can see what's going on. Okie dokie, so we'll put some a little bit of gunk on there. Put that on there as well. Legs just slightly bent. That should come through the holes like so. And get the screws with the washers. That's the wrong screws. Getting caught on the PCB slightly. Do that one up. Do a very quick continuity check with my little meter to make sure that's not connected to that, which it's not, but it is connected to that. Okay, yep, that's that one, and then we'll get lobby on there and there. Oops. Not finding its way through the hole there. Come on. There it is. Through the holes. Oh, take that back out. I forgot to put blobby on the underside of the transistor, didn't I? Silly Billy. So So let's squeeze it underneath. Look. Let's take it out. More haste, less speed, as they say. And that was me hurrying a little bit. Okay, and again a quick continuity test. Those two shouldn't be touching. That's right. Those two are not touching, but that one connects to that one, and that one connects to that one, and that one, and that one are not touching. Right. Electrically tested. Let's solder them in. Why didn't I clean those legs off first? Silly, silly, silly. Happy with that at all. Oh, that's better. Right. So we know TR7 and TR8 are okay because we've just replaced those. But we'll just do a quick side-by-side comparison of those two. Let's zoom out that bit a little bit because it needs to be a bit down there. So we go base emitter on the good one. Oh, let's turn on the equipment cam. TR7 base emitter, we've got 274. Let's go on this one. 274, nearly. Let's do reverse of that one. And about the same. About the same. Let's go base emitter on TR8. So we got 16 eventually. Do a reverse on that one. Again 12. And that one's 16, 17. So we're slightly high base emitter on it. Well, let's go collector to emitter on this one. We've got 15.9. Let's go collector emitter on this one. That's 5k out. That's going to be enough to unbalance this amplifier, I'm sure. Let's go same way around, positive on the collector, negative on the emitter of this one. 4.7, and on this one 9. That is what I would call significantly different. Okay, well, I'm afraid the eureka moment wasn't captured on video because I was going around in circles. I had to stop for a cup of tea, came back, carried on working, forgot to start recording. But I'm pretty sure I have found the cause of our low resistance across D10, and it actually turns out to be transistor TR3, which basically is a ZTX 504. Datasheet says it is something like a PNP silicon transistor, not massively different to similar sort of transistors, but if we look at it on testing, I've connected it up to my test meter. Let me just get rid of the diagram for a moment and show you. I found it basically, I just basically kept on disconnecting things all the way around the circuitry until I got to up here when the resistance changed across D10. Got to this transistor and it just, the only thing it could be was that, so I disconnected a couple of legs and the resistance went shooting up to 15k. So got the transistor out, got it coupled up. Let's power up the tester, and it's quite surprising how it comes back. It comes back as basically a double-ended diode. Now I know that there are some transistors which they look like they are transistors but are in fact double-ended diodes, so the only way I'm going to actually prove this is to take out another one, because TR4 is also the same transistor. So I'm going to do that and then connect that up, remembering that the black went to this leg with the flat face downwards and the brown in the middle. So if we leave it like that and take out TR4, which is right next door to it, just there. So this is TR4. thin little legs. I just need to push them with the soldering iron to release the solder underneath them, and that should be enough. So TR4 comes out and it's in exactly the same configuration, and out she comes. So that's now exactly in exactly the same configuration as the other one. Let's connect that up on my tester. So black lead on the outside, brown in the middle, and red on this side. And switch it. Oh, the things come off. Why does it come off? The middle there. I'll switch that off and do it again. Right, let's try again. And that says it's a silicon PNP transistor, which is exactly what it should be. Okay, so let's take this known good one out, put this suspect one back in, switch it back on, and it now says it's a double-ended diode, as you can see. So we have found the fault. 99.9% certain of that. So we will pop that into our bin of faulty components. We will put this transistor back into its place, into the other place, and then we will find an equivalent for that. ZTX504 can be replaced by BC639, BC640 respectively. So BC640, BC640. There we go. I knew I would have some of these because I've replaced these in the past. And they are, the two collectors go to R23. Yep. Right, I've triple checked that. So should now be able to go around and resolder all these connections that I unsoldered, put back the components that I've taken out, and check it, and we should get a similar set of readings to that one before we turn it on. He says, and I still can't see what I'm looking at on there. Right, so I'll quickly whiz through this hopefully. Might have D10. Not going that way. Put some pattern to C2 position. Next on ground. C2. Ground. Yep. I'll just do it with a corner. And so now we should be able to go across D10 and have something more than 4K reading there. and we're up to 9k, same as we are on D10 on there. Yep. Right, and let's put the equipment camera back up there so we can see one lot of volts on one side, one lot of volts on the other side, and I think we're ready to go. So variac is on, output is on. Let's go some volts. So we've got minus 0.8 on both, minus 2 on the others. We're coming up. We're now 4, and then minus 110 millivolts on the other channel. So that one is the good channel. Let's just whack it up a little bit more. I don't like the fact that we've got 6 volts across the speakers on this channel. Seven volts, and that one was still right, so I don't like that at all. So this channel I think is still faulty. Let's just bring it up again. So it's minus 2 on both of those. That goes to 0, and then minus 5. Somebody once said to me, you don't bring DC amplifiers up on a variac because they will inevitably trip out. Yeah, and we got 5 volts across the speakers of this. I don't like this. So I think we've still got a fault on that. Which is a shame. I'm thinking we had it right. Mind you, we've got no load on this either, so let's put speakers across it. So let's go do some DC volts checks. So let's bring it back up. So on there we should have minus 4 volts. Let's go minus 5. And that should be plus 5. On the collector of those, 4.8. Right, collector of that one, we got 4.8. Collector of that one, 4.8. Collector of this one, minus 0.8. Collector of this one, minus 1.6. Collector 1 driver, 4.4 and 0.7. So it should be 0.7 at the top if it's the same. 0.8 minus 4. Just bring it up a little bit more. We're barely at 25 volts there. Minus 0.1 on there, and 5. That should be 5. And 4 on there. Yeah, something's not right with this. Now, we have got a working voltage on here. The collector of TR7, which is that one, should be 0 volts, and it's 5 volts. Collector of TR7 on here is 0.7. So the base of TR7 should be 0.6. And we've got 5. Base of this one and we've got 5 volts. It should be 0.6. Maybe until it's not turned on properly. So it's TR7 base 0.6 and collector 0.9. Collector minus 0.7. Oh, sorry. Collector 7. Collector 7 volts on this one. And 0.9. Yeah, that definitely not right. Okay, next day, it's going to be a busy day. Basically, I'm going to take this channel out of the main system again and do more measurements, because it's not working correctly. Therefore, there's got to be something else wrong, and I'm hoping that again I'll do a resistance to resistance comparison with the other channel that is working, and hopefully find it, because I've done a lot of research, and there's quite possibility of more than that one transistor that I changed yesterday, as well as the output pair and the drivers. There could be another transistor or two, or some resistors that have also failed. So I can only really do that with this out of the board, and that's what I'm going to do right now. So we're disconnected from the power. Paper to wrap the end of it round so I don't get heatsink compound everywhere again. As we replaced TR3, so let's go for TR4, which I'm pretty sure we checked as well. Those two 9.5. Let's do that again. 9.4, and that's significantly different there. 1.8k, 2k. What was this again? 9k. So it's quite a significant difference in resistance readings across that one. TR3, let's go TR1 as well. Bottom 2, is that TR1? Yeah. That's open, so I think we're going to come back to this TR4, and that's got 500 ohms there, and this one's got 9k. So let's have a little look at the circuit. Looking at TR4, so we're going across base emitter, 9k one way, 9k the other way, across TR4, because the other thing we ought to triple check is that we've actually put TR3 in correctly. That's a BC640. So on the circuit, let's zoom in that a little bit more. So the emitter of TR3, which is the bottom one on the diagram, is it? No, the emitter is the top one. So I've got a funny feeling I might have put this in wrong. That might explain why it ain't working right. So get the correct layout. It's collector. So that's collector. That's base. That's collector. That's base. So that's collector. So collector to collector. So on the circuit, if we look at the circuit, the two collectors are joined together, correct? Ah. The BC640. Yeah, I've got this in wrong. Right, so let's look at that again. Flat side towards you. Pin 1 is the base. Pin 2 is the collector. Pin 3 is the emitter. So yes, I have got this transistor in wrong. That's where I've gone wrong. See, just goes to show you've got to have the right diagrams. So the two collectors should go together, and the two emitters go together. The emitter's a base, that's it. So TR4 base is that middle one, should go to emitter of that one. Yeah. No, it should go to the base. Right, so that's definitely wrong. Let's take that little transistor out and try again. So now let's get this round the right way. So that's base, that's collector, that's emitter. Right, base, collector, emitters. Just triple check that. That orientation, the bottom one is, the middle one is the collector, yeah. That edge there is the emitter, goes to R18. Yeah. Collector goes to that collector, and that one goes to base. Right, so we are now correctly orientated. Now, we were last time seeing we had volts that we could check on the emitter of TR4, base of TR7, which is here. There's the base of TR7. So power on, 0 volts, output on, base of TR7, 1.4 volts, two volts. So we're seeing 2 volts on the base of TR7, and we should only see 0.6. Let's just go quickly on the other channel. Base of TR7, which is that one. Did we see this voltage come up as well? Yes, we did. So at about 25 volts input. Right, so at that point there, on the base of TR7, we've got 4 volts. And the base of this TR7, we've also got 4 volts. Ah, so we're about the same. So let's go up to that point there. We got 8 volts on TR7 base. Similarly, we've got 8 volts on TR7. 9 volts, 10 volts, 11 volts. We've got the same voltage. We were getting different voltages the other day. So emitter of TR7, we should have 0 volts. We've got 15 volts on that one. What have we got on this one? Also 15 volts. We're up to 110 volts input. We've not blown any fuses, and that's emitter is sitting at 22 volts. Ah, and at that point there is when it drops. It's dropping down to, was it my probe slipping off? 25 volts on the emitter of TR7. TR7 emitter, 25 volts. 26, 27, 28 volts. I'm wondering if the it's not blown any fuses. We've got minus 28 volts and plus 28 volts. We're now at 150 volts mains input. Stick to base TR7. 32 volts at this point. We go base of that. Whoops. Base we got 32, emitter 33, base 32, emitter 33. Let's keep going up. Now this should be working, so therefore oh, I'll tell you what, it would help if I actually connect the speakers, wouldn't it? Right, let's turn it back down again. We are working. I think we've fixed it. Now we've got a hum on the right hand channel. Is that the channel that was 150 volts input? Full voltage. And it's on. Stable 51 volts, stable minus 51 volts. I think we're good. Right, the big test is, does it work if I power it off? Now these do have a known thump when you switch them on. Other amplifiers, they've got a relay that you switch in, gets switched in, that switch on, and then it switches on later on when the output stage is working. So I'm just going to do a power on and see what happens. Tune for maximum smoke. I'll tell you what, let's get rid of the diagram. Right, so if it's going to blow, we shall see magic smoke when I turn this on. Ready? 3, 2, 1. No flashes, no bangs, no magic smoke. Hey, we are fixed. We are fixed. Yeah. Power it off. Take it off. Let's go raw mains input. So we're on raw mains. It should still be working. Yeah. Fandabby-dozy. Right. So, having done that, I'm happy this is working. I'm going to let it cool down. I want to get it all boxed up, put it back together and leave it on soak test, but I've also got to connect it up to the preamp unit. So we should be a complete repair job done.